Hello and welcome back to Compiler Programming. Today I want to introduce a concept of compile time, or they're called compile time in Zig. They're called baked arguments in Jai. I'm not sure which other languages really have this concept in this form, but the idea is that you can have generic or non-generic arguments that must be known at compile time, and then you will get a specialized function where body is compiled with this knowledge in mind. Now, technically, we already support this with macros. So if we look at something like this make arithmetic operation module, so if we pass the type in here, it is sort of a closed over as a closure, but compile time closure in here, and we can use it in positions where we would expect a compile time value, and all of this sort of works, but in a sense it works incidentally. So if I put something here that is not a compile time value, I will get a very strange error, and also it's not like, so macros right now are basically only useful for these things. There are very few instances of macros used in Prelude, and I think this is basically the only real interesting use. I think another one is in allocate. Yeah, and here it's sort of the same situation where we need to make sure that the type here is compile time known. So ideally what I would want to do is something like, say, in function, and then so the first thing is, would be nice if I was able to use the compile time known things in here, but I think that's a separate issue. But also I should be able to somehow say, okay, actually, type is a static value, and this function will then be specialized to this particular value, which means that this will be compile time expression as it is right now, and it will not exist in the runtime, which is very important because ideally later on we will also make this allocate bytes be an inline function, and then all of these should collapse into like just some pointer math and not a function call, and this is very important to be able to do efficient code. So in sense, yeah, we are trading here size of the binary for the for the performance of the code, but that is a trade that should be available to the developer, and it's on me sort of to provide this. Okay, so for now I'll undo this because let's start with a smaller use case, and we can go from there. So what do we want to do? Well, we want to copy some kind of test. I don't know what would be a good test, doesn't matter. Let's take this one and let's put it before constraints. And we would say should support statically known. We want to support it everywhere or just on generics. I guess let's do first non-generic version, and then we'll see how it's end up being, and then maybe generic will just sort of happen automatically, but I don't know. Setting known values for, I'm not sure how to phrase it correctly, should support functions requiring statically known arcs, something like that. And here we would say something like static yeah, let's call it static add. and we would say that this is U64. Oh, sort of, we can do I64, doesn't matter. I started to get rid of these unsigned and signed types. I have more plans on how to make it nicer, because right now it's not exactly super nice to deal with, especially comparisons are a bit awkward, but that's not the topic for today. Adding them up is perfectly fine, so let's just do that. And we need to figure out a syntax for this. I'm not settled on anything right now, so I'll just put whatever makes sense. So we'll just say, okay, this function is only ever called if, well, this is not even going to be a function in a sense. This will compile out to, well, technically, yeah, technically it will stay a function. It will just be a function with 0 arguments. Maybe that's not a good test for this kind of stuff. So let's do something different. Let's do static identity, because what I want to test is in here that static 64. Yeah, this is fine. And now I would say like saved or I don't know, internal. Doesn't matter what we call it here. It's an X, and then we return internal. So the idea here is that this is a static expression, and if this is not static, then it will fail right here. And now we can do static identity of 42. That seems reasonable. Let's start with trying to run this. Hopefully we will get an error here because we have not implemented it yet, but let's see what actually happens. Maybe we'll crash or something like this. Yeah, okay, so it says invalid identifier at 126, and that is actually correct. So if you look in here, it's like 26 bytes from the start. So it says right here we have an invalid identifier. Great. That is perfectly fine. And now we can go to the we are doing this, which is header, maybe something like this. Yes, this is roughly where we are, and because this is parse function literal, and we can try to figure out how all of that is going to work. So this is where we parse function parameters. Let's go into that function and look at what we have. Yeah, this is we have token match argument. Great, great, great. Now this is the sort of known static where we are matching against exact value. Then in here equals, okay, infer type, fine. Okay, so we are splitting, and right now we are in this branch, and this is the error that we are getting. So let's try to figure this out. How are we going to do this? Well, the first thing, let's try to just make it not fail, and then we will make it better from there. How would that look like? Well, we can do a switch of name tokens length, and then we would have default break, and in here we would say case 1. So if it's 1, it's exactly what we had before. So we would say this, and if it is not a symbol, then we are very sad, and we're just saying that it's an error, and we are doing go to error. Okay, so this is fine. This is what we had before. Now we can do here. Okay, I think in here better thing would be parse error, to be honest, just more generic one because you don't know what was expected there. And now we have a case where there are two of them, and if we have two of them, then what? Well, we do the same thing here, and we would also have value star. Let's do value star first and second. So if either of them, so yeah, if it's not a symbol, then we do this. For now, I'm not worrying about this code being concise. I'm just trying to make it work, and then there is always a possibility to clean up later. Okay, so if either of them are not symbols, then it's bad for us. Then we also need to say if value as symbol first is not text compilation common symbols operator at. So here we are basically matching against this thing and checking if it is exactly this. So it's not at. Well, we can probably do this as well. I can probably provide a detailed message is slice literal expected at token here. That's fine. Then the source range is first source range. Okay, so this is the parsing part. Now we know that the first thing is at, the second thing is token, and we can do name token. Name token is second. So let's try the build, see how many mistakes I made. Yeah, we don't want error here because it's already a tag of error. Okay, that looks good. Obviously, we didn't actually implement anything, but now we should get an error in a different place. So we should get an error here because x is now a runtime value, and we didn't do what we actually needed to do. But let's verify that. Yeah, exactly. So we have expected value to be static at 126. That is, yeah, it sort of complains again that this value coming from here is not static. I think I need to update the source range to point to here instead of there, but that is it's details that are not important at the moment. It's also probably useful to try to run the full suite of tests to make sure that with that change we didn't break anything that was there before. And it looks like we didn't. That's a good way to add to the index, and we can continue working on this stuff. So the thing that we need to do now is we need to somehow say that we are expecting a static here. So I think the most type-safe thing to do would be to add another function parameter, and that hopefully will guide us through the rest of the program, telling where to do this. So I think we can just do static here, and then we can also do slight refactoring in here and remove the generic variable, and instead of it do this function parameter tag, and then say parameter tag is function parameter tag. So by default we consider it runtime. It's a separate code path. This is also okay. So let's see where we use generic. Okay, yes. So here we say if not this, and then we say parameter tag is function parameter tag generic. Also, now that I'm thinking, if we have both generic and runtime that can be marked as static later on, maybe that's not good. But maybe it is fine to just not make it flags, but just spread it out, and we'll have generic, and then we'll have static generic. I think maybe that's better. So yeah, continuing with what I had, and here we say if parameter tag is generic. That's great. And in here now we can probably do this and remove this and say parameter tag generic. Okay. So that's fine, but before we do this switch, so let me remove this again. Now the code should build. And again, if we disable this, then we should still get working code if I haven't messed up anywhere. Looks like I haven't. That is great. Getting back here and getting back to adding this static. Okay, so this thing is inferring the return type. And here it just tries to make it, yeah. I think it doesn't matter here, probably. This is actually a tricky one. So what this code does is that we have support now for stuff like this, which is something I recently added. You can say that I don't like just infer the type of the return, and again the syntax is very provisional, so it might change, but the point is that we can, if we know that the type of the argument, we can figure out the type of the return. But if we have these static ones, then we can't really do that because we might end up with a wrong type. And so the reason I'm saying this is, imagine here I would have something like type of x is I64, then x, otherwise right. So if I have something like that in here, then we have a problem, because this is yeah, sorry, I'm mixing up my language and C, but we this is a statically known if expression. So if we know that, then this branch will never be evaluated, and we'll just go here. But if the type is not going to be that, or even more so, like if this is like this, and it's exactly 42, then we return it. Otherwise, we return a string. So now suddenly the infer type is completely broken, because we expect to get a different thing from the function from what we actually expected. So that is very, very interesting. I need to think about it. I don't think, like, I think we can still implement the basic version and then go from there, but it's something to consider. So maybe what would be the right thing to do in here is to actually do, yeah, so here I think in here we would for now say that we don't expect this to happen. So if you have inferred types, we don't support this. Panic to do support static args in with inferred return types, something like that. Who is next? So this is the scoring thing, and in here we are so here we do need to handle it. If the value that we're trying to pass is not compound unknown, then this is not what we get. And then in here, instead of doing this, we are doing maybe this would be a better score. Not sure about implicit casts in this case. Like the whole thing, still haven't decided what to do about casts, because they are useful in certain very limited circumstances, but they make all of these function overloading such a mess, because like if the language only had runtime functions, then everything would be super simple. But because we have compile time functions, and we have a thing like compile time values that are not presented at runtime at all, and they degrade into specific runtime values, then we have issues. But yeah, I know it's probably sounding way too abstract, so let's just continue on this, and again we will take the most conservative approach, and then I will see if it causes any issues, and we'll go from there. So if it is the same type, actually if it's not the same type, then we just say return -1 and descriptor, source descriptor. Yeah, that seems perfectly fine. Okay, I think that's what we want, but we'll see if I'm correct. And then we have another one. This is also about inference. So let's just say that we don't expect this. Well, let's be nice. Panic to do, but there is one more place where we actually need to take care of this, which is, yeah, it's actually somewhere here. Yes. If function parameter tag is generic, then we do this. What do you want to do for compile time? Sorry, for static ones. This checks time constraint. This does this stuff. I'm not sure we need either of those things. Let me quickly consider this. So yeah, I think I don't need to do anything here, but we'll see if that is actually the case. I do need to do something in this function. Where is it? It's in here. So what this function does is it gets the signature of the function, it gets the body, or optionally it gets the body, and it gets and it tries to figure out what is the right, so what are the types for all of the argument for all the parameters, so concrete types. If we have the templated stuff, I don't know, wherever that was, so if you go back here, so if you have something like this, we do need to know what is a concrete type of X before we can create a real runtime function, because the ABI depends on it and all kinds of stuff depend on it. This is what this thing does. So in here, okay, no, I was wrong. So this is not about inference. So in here, we actually do need to support this, or actually in here, this should be unreachable because these the static tags should have been substituted already. And yeah, we do need to do stuff here. I was first correct. So if param tag is this, else, and I think fix me turn this into a switch. But if we are static, okay. So this is the first level of specialization where we can actually say that if arg this value is compile time known of arg, so if we don't know what the arg is and we expect the static, then it's definitely not something we care about. And I'm starting to get very worried here because it seems that this function is, if we are using it in other places, then it we have problems with memory. But that's not the topic. So, okay, if we have a static, if it's not a compiled unknown, then fine. Otherwise, we actually probably want to substitute the static param with the exact static. So we do param, or actually we do specialized param tag is no, param tag exact static, and then specialized param exact static value is arc. Exact static then. Oh, it has a descriptor in storage, right? Descriptor is arc descriptor, and then in here we say storage is and descriptor. Okay. Value is forced of arc storage. Mm. Okay, descriptor is in different place. Yes. Let's verify. Yeah. Okay. So we only need storage actually here. So that kind of makes sense to me. But we still haven't actually dealt with this thing here. So we do this stuff, but we need to say parameter tag is static. So let's actually add the breakpoint and see what is going to happen. First, the question is, do we even get to here? And then we will see from there if we are doing the right thing. Stop here. Okay, so it looks like we correctly parsed our static parameter definition, and we ended up in here. We pass the compile time known 42, so this thing over here. So far so good. We'll actually fail probably at this line, but that's not really important. Okay, so we specialize, we put in here. Great, great, great. We go in here. Define the types. Yeah, we didn't really even need to do this because in here we know the, yeah, we end up in this case. So that's great. Get the descriptor here, we do. Why is it generic though? Yeah, not sure. Anyhow, that's not the stuff. I think we are actually quite successful. So let's try to run it further, and we explode in terrible, terrible ways. Let's see what happens. Right. So this is kinda So what is the issue actually? Ah, the descriptor is not set. Right. I think we can fix that. Not sure if this is the right place to do that, but we can do this actual descriptor. Descriptor. Let's try that. So here we seem to get the right one. We get into here. We are trying to match this 42 against the sort of itself. So this should now be perfectly fine. We have an exact match. That's great. See what happens from now on. Okay, well, we at least didn't crash anymore. Let's see if it's successful, but I think it will be. Or not. Undefined variable x. Here, I do get the second. Okay. There's probably an issue here. You scope define. This seems wrong. Just straight up not what should be happening. So this stuff goes through the parameters and defines them in the function, but I think that's the wrong thing, to be honest. Like it doesn't actually handle the exact static. So here, switch case. So I don't have to type it all again. So if it is a runtime, or if it was generic, then what we were doing is correct. But if it is a static one, then so here we should not arrive. I think into here should have been resolved earlier. I think. So we can extract up. Okay. this. I think I want to assert this. Oh, just do it like this. It will crash anyway if it's not there. Um, so value static epoch, and then I think there's going to be a bigger issue that I will need to deal with. Because probably in here, exact static, yeah. So, ooh, this is nasty. It's the Windows one. Yeah. So the code that deals with the ABI, so like which arguments go into which registers, it sort of correctly skips the parameters that are exact static, but then yeah, so it seems like they're not actually available in the body of the function, which is very, very awkward. Because they're not handled here. But what is even more awkward is that we would have misalignment between the call parameter here and the one that was defined because the statics has skipped. Yeah, that's a big yikes. How do I want to deal with that? Think actually this is very, very awkward. But I think we can still make it work. So what we are going to do is we are going to say that this is handled above. I definitely will need a bunch of cleanup time after this, but I want this video to actually finish in somewhat reasonable time. But okay, info parameters. So first we go through the parameters that will be mapped to registers or stack memory, and we do this style. Okay, that's fine. And then we go through here. We assume that this is runtime or generic, and we can actually assert here that def param tag is, or def param tag is. I feel like I need to create another type because there seems to be this disconnect between runtime and generic types and the static types, but just thinking out loud here. So we get this, we get param, fine. So this is handled above because this is what we assert here, and then this shouldn't be here at all. But for this thing, we would get symbol, and the value is param descriptor, param source range, and storage is gonna be param exact static storage. Okay, and we put the storage in here. Let's add this as well. Okay, so now what's going to happen is we go through this thing, this will do exactly what I did before, and then we go through this thing and it will do fine. There is still a problem of a mismatched eyes. Fix me. I don't know if I can go ahead and not do this right now, so let's just still add a fix me. These indexes can be mismatched in the presence of exact static params, just static params. Okay, so let's now jump into this function and see where we are. Okay, so which function are we actually building? Literal body. Okay, so this is the first function, it's not the interesting one. Okay, yeah, this is okay. And this was okay, you already checked that. Now we should be building the right function. Let's verify that before I try to debug it. Body. Yeah, okay, so this is the right one. And let's see what happens. So we should have 0 call parameters. So this should be skipped. Yeah, great. And now we go into here. We go into exact static. We define it as static. And we are done. Let's try to run it. Okay, so didn't crash, but did it actually do the right thing? Okay, it did do the right thing for this particular case. Now the question is what's going to happen here? And we are gonna try like this. Okay, so this worked. Now let's see if we can get this working for generics, but before we do, let's commit this stuff. Git log pipe rg episode /a plus. Okay, so we are on episode 186. Git commit ism episode 186 support non-generic static params. Okay. Now, now that I'm thinking about it, I think the way I did it is slightly wrong. So this static should actually be a property on generic over here because they have the same thing. Like, because every time you provide a new static, you create a new copy of the function. So whatever code I had that dealt with the fact that when you have a generic parameter, you have a copy of the function, that should be the same. So I think we're actually gonna remove it back, and I know we just added it, but that's fine. And then here we say is static, something like this. yeah, let's try this out. So what changes will we have then? So we will have generic, and we will have is static generic is true. To put this here as well. Bool is false. I really don't like this function, but I don't want to go into trying to do something with it right now. Function parameter generic with the type constraint, and then we also say that is static in here. Okay, that's fine. Fine, I guess. Generic. Just look up. I think you should just fall to this branch, so it should be okay. Yeah, okay. So this is good. So in here, if we are not compile time, and not param generic is static, then we do this. If there is a type constraint, we apply the type constraint. And we say if param generic is static, we do what we did before, or more like we are saying that if I'm not exactly sure in which order these need to go. Well, let's just say this is correct one, but it is unclear. Let's try it this way. Okay, so then we can remove this stuff, I guess. And then, yeah, we still need to follow through, assert not, or if the param generic is static, panic to do. Have to do this in another place as well. Yeah, that's not happening anymore. So yeah, this is not also really not happening. Let's see if this all still works. Looks like we are fine. Yeah. And now we're going to add statically known templated parameters. Okay, so the trick here is we are doing this, and we are saying this. And now we're going to figure out if that works. For that, we need to get back to parse function parameters, and let's see what's going to happen. Actually, token match argument is the right function. So let's see. We try to split on this. Okay, that's fine. Fine. Okay. So I think we will end up in the same. Yeah. I think we will end up in the same place regardless. I think this is fine-ish. Well, I guess there is only one way to find out, and that is to run this new test. And it works. Great. So yeah, that means now we have this stuff, and we can verify that it works. I think I'll later turn it on a test, but I still need to. I'll probably need to add way more tests about this, but for now, let's just verify it like this. So now this should fail. Yeah, great. I can actually add this as a test as well and say that should not match templated parameter and static templated parameter to non-static value. Cool. So I think now the test should pass, or it would if I did it right. Yep, that's great. We can rerun all the tests. And we are good. Okay, I'm pretty happy with that. This is a feature that I was thinking about for a long time, and there is still stuff to think about, like that thing with inferred types, and I need to fix out call parameters. But I think it was a good video, good progress on this stuff. So yeah, that's it for today. Thank you very much for watching, and hopefully see you next time.